And welcome to Module 6 of our Technology and Leadership slides. Hey, I have to confess something to you. This is actually the second time I've recorded this lecture. I just finished recording it, I thought, only to learn that my microphone was off, if you've ever had one of those kinds of days. So this should either be really good because I've practiced it, or I'm going to go through it faster because I will feel like I already said that. Anyway, that's what's happening on my end of the microphone. I hope things are going well for you. I hope the course is going well for you. Remember, you can reach out to me via email if you need to, and I'll be happy to respond. If you're on campus and we have to get together, then we can probably work something out for that as well. We're in Module 6. We're going to talk about software development methodologies, and this is a critical part of what you're going to have as an organization. Just about every organization does some level of some kind of software development. By organization, I mean company. Now, not everyone does. There are plenty of small companies that don't have any need for unique custom software or certainly can't afford it. And so they don't go through this. But most organizations that are of any size will probably do a little bit of development of some kind or another. So let's get into it. Let's find out what this is. Software development methodology. What we're really talking about here is the creation of software, the creation of software programs, and what approach are we going to take to get there? It's not just, I've said here, called it creation or design. It's not just creation or design. It is how are we going to go from I have an idea that if we could write this software, then we could get these actual productivity improvements. Or if we write this software, we could sell it to our customers and they would pay us good money for it. And so this is the idea of how do we get from the idea all the way to the final product that we can either use or sell ourselves. Now, one of the things that is critical that you've got to keep, pounded into your brain when it comes to software development is that it is malleable. Software can be changed, I say easily, and by easily I don't mean changed correctly easily. I mean it's easy for people to go in and write a few lines of code and change your software, whether that's for the better or for the worse. That's going to be up for other people to decide. Think about how other kinds of things are built. I have the example of a bridge here. Somebody says, hey, we've got to build a bridge across this wide chasm because that would improve traffic flow in our city or in this part of the country or whatever it is. And so they go through the process of analyzing them. The gap, they look at what kind of bridges they can build, they design what they're going to do, then they come up with their designs, they buy the materials, and the construction companies come out. And once they get that thing built, you're not going to change it unless there's something seriously discovered wrong with that thing. You're not going to change it. It is done. It is set. And, you look around, just look around. How many bridges have been around for tens, if not in some places in Europe, hundreds of years, and they don't change. Or if they change in sort of a simple or not very serious way anyway. But that's not how software works. Software is constantly changing. And if there's one word that goes with software development, it is the idea of change. And when we think about software methodology, software development methodology, sorry, what we're really talking about is how do we embrace that change? The idea that our software is going to remain static is just absolutely naive. And you as a leader, anybody who you talk to who thinks, well, we'll build this thing and then we'll be done, then that's the kind of thing that you can politely, help them understand that no, software is never, quote, done. The only software that's done, the only software that's finished is the software that has reached end of life and is no longer available for people to use. Or if it is, they even know, well, this is like 20 years old and I'm not going to get anybody to support this thing or make any changes. Any software that's still live, any software that's still being used and supported is probably also being changed. And as a result, when you create or design software products, the process you go through must be one that takes the idea of change in mind. And so software methodologies have changed. They themselves have changed over the last 40, 45, 50, 60 years because this truth about software change has become self-evident. So when we look at software development, we are concerned with the processes that get us from point A to point B, the practices that people go through, the way in which we organize ourselves, and the principles, one of which is change is a permanent feature of software creation. That's what we're looking about with that's what we're looking at with software development methodology. Software development methodology is going to outline the approach that a dev team will take to go from the initial idea to a quote unquote final product, at least final version one product, we'll put it that way. The factors that influence the methods that we use include the size and scope of the project. Obviously, very tiny projects can be treated a little differently than big projects. So if you have a huge project, you have to really put all of our best methods into place. But if it's a really tiny thing, maybe we can punch it out a lot faster, and we can, you know, speed up or combine some of the different steps we might have to go through. And that also is related to the complexity of the project. But that's not just the project side that's important. It's also, hey, how experienced are my programmers? How experienced are my developers and designers? How good are they at this stuff? And so that can also come into play. If your people are fairly young and new, then you may have to take that into account in your process. So when we look at software dev, we're looking at, hey, is there a defined approach? And thankfully, there is a defined approach. Things like team dynamics, activities, and communication methods, these are all described in some of the several this development approaches that are out there. The old school, we're looking at like 50 years ago and maybe even 10 years ago in some organizations. I certainly am aware of a few that still think this way, and I actually, I don't say a worry for them, but I think, wow, they really need to change. And there's that word again. So in the early days, people actually looked at, well, we're going to write software, and the engineers and software programmers said, okay, this is our approach. If we build a bridge, we do this and this and this and this, and the bridge is done. And they kind of took that same approach to software development. We're going to gather requirements, and when we have all the requirements and the user has signed off on them, then we will go away. We will return to our ivory tower and we will do a design, how we're going to build this thing. Then we might mock up a few prototypes and begin to implement. And when we have it implemented, we will verify that we met the requirements that the user signed off on way back in step one. And then our final verification step will be to take the software to the user. The users will look at it and say, oh man, this is awful. Now, hopefully they'll look at it and say, okay, we will take this product as is, and then we're going to ask you to maintain it. So that's the last step in the waterfall method. One thing that you don't see in the waterfall method is constant communication between the customers and the developers. There's kind of a, we're going to go away, and there's this idea that we will go through our development process and then we will give you the bridge at the end and you will be happy with it. But in fact, what is true in software is when you deliver the final product, if you have not been in constant communication with your users or clients, they will not be happy with it. They will look at it and say, that isn't what we meant. Because even the best requirements gathering people cannot get everything exactly right. And even the best users cannot anticipate everything that they would like to see or think of all the little nuances that go along with screen A and screen B and screen C or these different images. So the waterfall method is doomed to failure because it goes out and gets stuff, comes back, works sort of monolithically, and then delivers it. Instead, we want to use a modern software development. Um, and when we think about the waterfall method, this idea that they're going to be set in stone is just absolutely ridiculous. It's doo-doo caca-poo-poo, as some people might say. And people figured that out some time ago. And so they began to look at, well, how can we have a process? Because we're all used to the idea of gathering requirements, building through the requirements. What should be wrong with that? If only these stupid users would tell us what they want, we would be able to go ahead and get this stuff developed in a way that worked. Um, what we've done in then is realize that, hey, we don't get perfect input, and if we would break our process up into smaller steps and had our users involved with this all along, yes, we will still do a major requirements analysis at the beginning, but that out of that will come a lot of tiny tasks, and we will work those tiny tasks one at a time with user input. And we will what? Embrace change. We will know that the requirements are going to change. They will not end up the same as they were when we started, and that's okay because software itself is highly conducive to change. So here's the first methodology. It's kind of a modern methodology, and you will see this in use a lot. This is an agile methodology, and this is an iterative approach to software development. And by iterative, we mean we're going to go through many, many small cycles, each of which will contribute to the large design, each of which is going to be testable and reviewable, each of which our users and clients will be involved in. You see that kind of that idea up here at the top with these 3 cycles, and it will be many more than that on any project of any size. Um, and so we have this: go through a cycle, develop some small pieces, go through another cycle, develop some more small pieces, go through a cycle, develop a framework, or a skeleton that looks right with a lot of filled in parts that don't do anything yet. And so agile methodology is an iterative, repeated approach. And as you're going through it, you're going to emphasize, hey, all the programmers are going to be flexible. All the programmers are going to collaborate not only with each other, but with the users. And we're going to be constantly looking for ways to improve the product that we're developing and the way in which we're developing. So unlike the waterfall method, which was kind of linear, beginning to end, this breaks it down into smaller steps, and we call those steps sprints. And you think of a sprint as a quick run. And so that's what this is. Each sprint focuses on a small feature among many that we know we're going to have to deliver. And that small feature can be reviewed and tested. We can get thumbs up from the clients, and the customer is involved all the way along. What Agile tries to do is try to prioritize the idea that we want this product to be what the user actually wants when we get to the end. And we don't get that by gathering requirements and then going away and hiding for a year and a half and coming back with a final project. We're going to prioritize customer satisfaction. We're going to prioritize communication and involvement from stakeholders. And we're going to encourage adaptability and change on the inside of our teams. So developers actually adjust their approach from traditional waterfall methods, and they respond to changing requirements or new information. And it's not something that should be upsetting to anybody, because we anticipate from the very beginning that it's going to happen, that change is going to happen at every step, every sprint. We're going to see some changes. So within Agile kind of says that we're going to go through these sprints, and we're going to cycle through, and we're going to knock off different parts of the big project. But how does the team work within a single sprint? We talk about this as the Scrum framework. And if you think of a Scrum, you think of like a rugby team, and they're all out there kind of pushing and pulling on the ball, and it's they're working together as one giant pile. Well, the Scrum is not much different from that. This is something that fits into the Agile method, and it describes the way the teams collaborate and communicate with each other as they go through the iterative increments of Agile. So what we do is we break down a task, and we say this task is going to be done in a sprint. And a sprint will be from 1 to 4 weeks, typically 2 weeks. And that time box focuses on that one task that we're going to try to, or maybe one or two, some number that our team can handle. And within that sprint, we focus on getting it done. And we have some specific interactions between the teams. There are 3 well-known roles within the Scrum framework. There's the product owner, and this is the person who represents the customer. I'm moving my hands. You can't see that. The customer's representation and participation in the development process. Represents an investment on their side too. You have to recognize that. And then we have the Scrum Master, and this is the person who understands, hey, this is how our team should operate. These are the kinds of communications that we should see among each other and with our customers. And they're really sort of like almost a project manager, but they're really more of a process manager. They keep everybody in line, they keep the communication going, they watch for the telltale signs that things are a little off and try to fix them before they become major problems. And then you also have all of your developers who are doing the work. Now, during a sprint, you actually hold daily stand-up meetings. And the idea behind a stand-up meeting is we're not going to come into a meeting, sit down, and hang out here for an hour and a half and discuss stuff. A stand-up meeting is supposed to be very quick, 10 minutes or less maybe. And the programmers and the product owner and the Scrum Master get together, and they talk about, what did we do yesterday? Any problems? What's going to happen today? What kinds of progress are we going to make today? And it's very focused and it's very tight. And so within that meeting, nobody has time to sit down. We're just going to go into the meeting room. We'll stand around. We'll talk to each other very quickly, and then we'll move out. And so we have daily stand-up meetings that focus on immediate problems and immediate results. At the end of every sprint, now we will have a sprint review where we are going to look at how did this go, what didn't work well, what should we change in the next go, and the customer again. Once again, that's the customer's involved in that. So what we get with these short sprints and this Scrum framework is fast delivery of small bite-sized chunks of pieces of our final project. And when we do it that way, we're able to, we don't have a year invested in the effort and find out, oh, we got to go back to month 6 and make some fundamental changes and then redo a bunch. When I'm working with my students in the lab, oftentimes I will give them a lab assignment sheet and I ask them to please get task 1 signed off before you go to task 2. And the reason I do that is because if they do task 1 wrong and then they come to me with task 2 and I say, well, you have to go back and redo task 1 over again, they are usually not very happy about that. And I don't blame them. I would not be happy either. And so this is kind of what the Scrum tries to avoid is getting way down the road and finding out, oh, you know what? When you were way back in week 3, you made a really stupid mistake, and now you have to redo everything from week 3 to week 20. And that's one of the things we're going to avoid with this. All right, we've talked mainly about development organizations, but there is a whole nother side of the house if we're going to have a successful software development methodology, and that is the operations folks. The developers are the programmers, the designers, the testers, those folks. But there is a whole group of organization that is responsible for making sure that we have computer platforms, hard drives, things are backed up, that the compute resources we need are available when we need them, that maintenance is occurring, that when the software was released to our customers, that there were good release methods and the customers could get to it. And these are the operations folks. They're operating our hardware data centers and compute resources, and they're also providing operational support for people who might be using our software. Certainly, they might be providing the hardware support if it's an in-house product. And so there's this idea historically that a lot of times programmers or the development folks kind of were at a friction point with the operations folks. And you can understand why. Some developers working on something and he realizes, the way we're writing this, I've got to have more compute resources. This is not going to work unless we have a higher performance, higher availability of CPUs, or I need more disk space right away. And so they put that request into the operations folks who provide that stuff. And the operations folks say, hey, no problem, we'll have that disk for you in 3 weeks. And the dev guy he's not happy about that because he says, hey, I can't do anything for 3 weeks because I don't have the disk space I need. And the ops guys say, well, you should have told us 3 weeks ago and we would have had it for you today when you needed it. So there's this kind of friction. Both sides look at the other side and say, well, if only they were reasonable in their request. And the other guy says, well, if only they had this stuff ready to go and could pump this stuff in a week and a half, or at least, faster than 3 weeks. So the operations folks are responsible for that part of it. What we do when we put a DevOps methodology in place is we say, we're going to bring these two groups together and we're going to try to increase high levels of collaboration. We're going to involve the operational folks a little bit in our development, and we'll try to get some of our dev folks to understand how the operations side works. But it's not just causing people to come together and meet and talk. We're also going to introduce some new processes. We're going to try to automate things. And one of the things that you will hear about is this idea of code platform control. And so what happens is we will have all of these compute resources available, and the configuration of them isn't just stored on the device itself, but rather is stored in scripts. So that if our entire data center wiped out, we could take those scripts, put new hardware in place, run the scripts, and it would auto configure everything for us. And if we want to add drives, if we want to reallocate CPU capabilities, we can do that by modifying the scripts and then running the scripts against existing hardware resources. And so in DevOps, we have both the operational and the development folks involved in the development of those scripts. We have scripts that control the configuration and provisioning of resources, but we also have scripts that control the integration of final Scrum and Sprint outputs into the existing quote unquote production code. And so we recognize we already would have different versions, production and development environments, but we now are going to automate that as much as possible. And by involving each of the teams together, and by also having things be more script based, then what we try to do is hey, can we reduce not only the friction between these, but can we make both of them more efficient? And that is the goal of what we call DevOps. And we want to improve the efficiency of our work together and also the quality of what we deliver. If we can do all that, then we have improved lowered the cost while improving what was delivered. And so I kind of already talked to this slide a little bit. One of the things we're going to do is automate as much as we can, and that also includes feedback and monitoring. Um, there will be people who are responsible in a DevOps world for watching how these processes are working. Are we seeing big delays in the provisioning of new resources? Is the actual deployment of new code taking too long? Why is it taking too long? Are we getting code out of one team that has a lower quality, higher error rate than others? Why is that team having the problem that they're having? So in a DevOps environment, we not only get collaboration, we not only automate things, but we also begin to measure things. And you will hear me say it again. I'll probably talk to it more at the end of this presentation. You improve what you measure. If you don't measure stuff, you probably cannot improve it. And we'll talk about why and more, but that's just a rule. If you don't measure it, you probably can't improve it. So that's the DevOps. There's another idea here, very important one, software development lifecycle. Now we talked about two different methodologies, the traditional and completely ridiculous waterfall method, and then the agile method. And both of them had kind of a cycle in it. You saw the waterfall method went from requirements to delivery in sort of one linear line. And the agile, each little sprint kind of went through a cycle. But even in the agile method, we still have, if you go up at a higher, more abstract level, we still have the idea that we do go through an idea phase, a requirements gathering phase. That requirements gathering phase will produce all of the little mini tasks we have. And then we will use our agile method to knock those out over time. And that's going to be our development. And there will be testing that's integrated. So it's not just develop, then test. It's actually develop and test as we go. And then there will be some deployment as we go, and there will be maintenance of what we have. And that's kind of what we see here with the software development lifecycle. And it's important for you to be aware of this as a leader, because you need to understand, hey, if we're going to do a big project, we are going to have experts who can handle this. We're also going to need to anticipate that these steps are going to take time. And so with SDLC, we recognize that there are different phases. And I've kind of given a sentence or so here about each of these phases. I think we've also talked to them a little bit in the previous slide. Perhaps one that we didn't talk about a lot and will only briefly refer to in the next slide on quality assurance is the idea of testing. Testing is not just having users who test software as it gets developed. We typically actually try to automate testing. And there's a big question always in the back of our mind of, have we written enough tests to cover most of the possible paths of execution that a program can go to? And so that is a really big part of it, something we didn't talk about previous to this. And here it is, quality assurance testing. QA, as the name implies, is the process of ensuring that software products and services meet or exceed, I'm reading this to you now, customer expectations. We want our products to have high quality. We want them to have minimal bugs. And I really cannot overstate the importance of quality assurance, the importance of having not only really good test methodologies in place, but also integrated testing in place and processes in place that force your programmers to be accountable and get them to recognize the importance of quality and work towards it at all times. So this can be different kinds of testing. There are unit tests, which are automated, integration tests that test how different pieces of the system work together. System test, hey, the whole system, does it work the way we expect it to? Acceptance testing, which often involves users. And QA involves a set of activities and different things that you do that focus on preventing errors before they occur. And so when teams are implementing or test procedures, they try to think about how can not only that the test will reveal if there's a problem, but what kinds of things can we move upstream in the software lifecycle so that in the design phase or in the development phase, we behave in such a way that these errors are found and fixed before we get to the test phase. So one of the ways that you do that is you track and you measure the quality of each different step as things are going along. And this really gets back to sort of a mantra of mine, something that I learned many years ago and have seen in action in every kind of organization that I've been involved in. If you want to improve something, maybe the quality of your product, if you want to improve the quality of your programmers, if you want to improve communication, You have to find metrics and ways to measure it. You cannot improve that which you do not measure. If you don't measure stuff and find some concrete ways to do that, then as a leader, it becomes more of, hey, I'm just going to do a gut feel, which may sometimes work, may not. But there is a magic that happens if you can figure out how to measure something, then you have data and it can help you identify with concrete insights why things are happening. They can point you in the right path for the improvements you want to make. But there's another magic thing when you begin to measure something. As soon as you begin to measure something, then people who are involved in that process begin to realize, hey, I'm being measured. And it's the same kind of effect as, and I definitely am not trying to make this sound like a big brother kind of a thing, but it's the same kind of effect. When you know people are watching, you're more careful about how things are. You do things with a more mindful approach. And so if you have good metrics on something you're trying to improve, you will not only get good data, be able to make good data driven decisions as a leader, and that's a critical part of this, but you will also be influencing the behavior of those people and that itself may bring about quality improvement. So keep that in mind. You can't improve what you don't measure. QA in software developing often is about developing metrics and measuring those quality metrics. And then that drives a total improvement. All right, finally, tools, tools, tools. Who doesn't like tools? Pardon me. Here I have my screwdriver, my hammer, and a wrench. You've heard the phrase, if all you have is a hammer, everything looks like a nail. And so you as a leader in an organization that may be going through software development, you should be aware of some of the different kinds of tools that people have at their disposal. Make sure they have good tools and a variety of tools and that they're using the tools in the right way. You don't drive a screw with a hammer, you go get a screwdriver or a drill to take care of that. And there are a ton of different kinds of software development tools. One of the first that some people overlook, sort of take for granted, is the programming languages and frameworks that you're going to use. Think about that. What language are you going to write your program in? What tool are you going to use to develop it? We teach C++ at Oklahoma Christian University to our freshmen, and that sometimes is questioned. Why do you teach C++? That's kind of an advanced language. Start them with something simple. And some people even wonder why we would teach C at all. I recently saw a list of the top 10. It was when I was doing some research for the IoT part of this course. What is the number one language used in Internet of Things products? What do you think? Just make a quick guess. Do 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 do. It's C. It's the C language. You probably knew that because I was mentioning that just a little bit ago. The C language turns out to be a fantastic language if you're going to deploy software in what's actually a very tiny platform with minimal memory and minimal processing. So I'm going to have to sneeze, so I may have to turn this off in just a sec. All right, so if you got to know what language is best for the environment you're in. C is not the right language for everything. Python isn't the right language for everything. Neither is Java or JavaScript or HTML. Use the right tool for the right job, and programming languages are one of your tools. Then there are the IDEs themselves. These are the programs that allow you to write the code. They do a lot of the development. Smart ones are really good at suggesting code, or they can auto write certain parts of the code for you. Then we have version control systems, things like um, GitHub and other repository management systems. These are absolutely essential for any kind of large endeavor, and you're going to have to decide as an organization which ones are you going to use. Then there are the automation tools for building and deployment your code. You should have scripts that automatically build your stuff, deploy it, move it out into the ops areas so that you have a nice DevOps environment. Of course, we want to have automated testing and tools as much as possible. And then finally, there's sort of the meta part of this, not just the action of writing code and deploying it, but how do we make our programmers work better together? How do we help them communicate better? So let's make sure we have good collaboration and communication platforms. So software development tools play an absolutely critical part of that, and it's important for you to be aware of them because they have such an impact on efficiency, collaboration, and using the right tool, for the right job makes a big difference. All right, finally, last slide, last topic in the world of software development in our very high level flyover. In or out, you have a new project, congrats. It's going to be a big one, and if it goes well, you're going to have a nice gold star. Maybe you'll be promoted after the project's over. But you have to decide, are you going to build this project inside with all your programmers that you have in place? Or are you going to hire an outside organization to develop? And what should you be thinking about? Well, the number one thing may be, how much is it going to cost? Is there a big cost differential? Sometimes actually people think, well, it's going to be cheaper in-house because I'm not going to have to pay somebody, for their profit margins. But in fact, the cost may be significantly higher if you develop it in-house because you have to hire the programmers and you have to pay their benefits and you have to find a place for them to be and you have to provide them with hardware to write their code on. And all of this extra cost comes along with it. And then when they're done with the project, if you don't have more work for them to do, you're going to have to go through the cost of letting people go, and that can be very harmful to an organization, and it can be very costly to an organization to let people go. If I just outsource this project, then I may be able to get people who are much, much more productive at this specific task than my current set of programmers. Or maybe they're going to bring expertise in-house. This is the second bullet. Maybe we're going to do a cloud-based operation. Nobody on my team has done cloud-based stuff yet. And so I'm going to outsource it and put two of my team members on the project so that they can develop this skill. But I'm not going to try to pay 30 of my inside guys to spend 6 months developing this skill and then write the project. That's going to cost me way too much money. So one of the key things for you as a leader here, are you going to assess the talents and how are you going to assess the talents within your organization? And that helps you determine, do I want to go inside or outside? What are some of the hidden costs around developing expertise inside? And they are there. Finally, there's also the idea of time to market. Outsourcing companies oftentimes are very, very efficient about developing and creating code. And it's because they have so many programmers. They're programmers, that's all they do. They're used to moving from project to project very quickly. They can get in, write code, and get out. So sometimes just the time to market can be improved by going to an outsourcing company. There's a downside though. You have to think about security. Security always comes into play here. And if you outsource something, then those outside companies may have to know about some of your inside sensitive corporate information. And you want to manage that risk. Are the benefits of an outsourced operation, if indeed there are benefits in that particular case, are they worth the risk? And how are you going to manage that? What will you do to manage that? So leaders like yourself should carefully evaluate all these factors, weighs this is like basic stuff, but you're going to weigh the pros and cons. But you need to be aware of what those pros and cons are. Don't be blind to inside and outside costs and then make a good decision with which way you're going to go. All right, that is the flyover for the idea of software development methodology, module 6. All right, get out there, write the assignment. By now, you know how these assignments are done. They all look basically the same. Good luck, and please let me know if there's anything I can do to help you.